How Ice Age giants inherited a world. The extinction events that built the Pleistocene. 20,000 years ago, these creatures were not conquering a virgin continent. They were standing on graves. The giants that ruled North America during the last ice age, the mammoths, the saber-tooth cats, the dire wolves, none of them were here by accident. Each one was a direct heir to catastrophe, shaped by the deaths of species that came before them. And the question nobody asks is this: what if the extinctions that built the world these giants inherited were not random geological violence, but a series of selections so precise that they almost seem designed to make room for the largest animals the continent has ever known? This video reveals something most documentaries skip over entirely. The Pleistocene was not a single climate system that mammals adapted to. It was a machine that destroyed competitors, cleared niches, and systematically elevated the winners higher and higher with each cycle. Stay with me, because by the time we reach the end, you will understand why extinction was not an ending for these giants. It was their foundation. If you found yourself watching Ice Age content at 3 in the morning, scrolling deeper and deeper, I want to hear about it in the comments. What species captured your imagination first? Was it the sheer size? The social behavior? I read every comment and I always respond. This is a community built on curiosity, and your perspective matters. And if you have not subscribed yet, now is the moment. The channel grows because viewers like you share these stories with others who feel the same pull toward the lost world. One more thing before we continue. Wait, I need to grab something important here. The complete mechanisms behind how extinction cycles built the megafauna hierarchy are mapped out in a full guide available in the description and pinned in the top comment. This is not a casual summary. It is a paid resource where the fossil evidence, the climate data, and the competitive anatomy behind every claim in this video are laid bare in a format you can study. The guide exists because this topic deserves more than a 30-minute explanation. Let's reset the clock. 65 million years ago, the dominant animals on this continent were not mammals. They were dinosaurs. When the asteroid fell and the dinosaurs vanished, a vacuum opened up. Mammalian species that had been hunted, confined to the shadows, living in burrows and small forest niches, suddenly inherited the entire continental real estate. But here is the catch that changes everything. The first mammals to expand into that space were small, very small. Rodents, shrews, insectivores, possums. The megafauna did not simply appear. They were assembled, piece by piece, through millions of years of climate cycling, competitive pressure, and selective extinction. The Pleistocene epoch started about 2.6 million years ago, and it was not a single cold period. It was a trapdoor that opened and closed over and over. Roughly every 100,000 years, the orbital mechanics of Earth changed just enough to plunge the northern hemisphere into glaciation. Massive ice sheets spread across Canada, the northern United States, and Europe. Temperatures fell. Vegetation patterns shifted violently. Species that could not adapt died. When the ice retreated, the system reset. Warmth returned. Forests expanded again. And when the next glaciation began, different species were caught unprepared. This was not chaos. This was a filter running on a timer. Each time the ice advanced, it killed indiscriminately, but it did not kill randomly. It eliminated species that lacked certain adaptations: thick fur, large body mass, the ability to digest tough, low-quality vegetation, the capacity to migrate across long distances following food sources. Small creatures, creatures tied to specific habitats, creatures that required year-round abundance. They perished first. What survived were the animals built for extremity. The animals that could handle starvation, cold, isolation, distance. 50,000 years ago, North America hosted creatures that were not simply large. They were incomparably large. A mammoth weighed up to 7 tons. A a ground sloth reared on its hind legs, stood 15 feet tall. A direwolf pack hunted prey in coordinated formations that required intelligence, memory, and social structure. These were not the survivors of random fortune. They were the inevitable output of a system that had eliminated everything smaller, everything less specialized, everything that could not endure. The ice cycles had run for nearly 3 million years. By the time the last glacial maximum arrived, 20,000 years ago, the giants had inherited a continent because every alternative had been erased. The real revelation is this. The extinction events that built the Pleistocene did not create giants by accident. They created giants by elimination. Every glaciation removed the competition. Every interglacial allowed the survivors to grow larger and more specialized. Smaller predators died out, making room for saber-tooth cats. Smaller herbivores perished, allowing mammoths and mastodons to expand into niches without rivals. The ecosystem was not a peaceful garden that housed many sizes of creatures. It was a hierarchy that had been violently compressed into a single bandwidth, the extreme end of the scale. This is what most paleontology resources miss. The giants were not anomalies. They were the only option left. Understanding how these creatures came to dominate requires stepping back even further. The Pleistocene did not begin with mammoths and mastodons already in place. It began with inheritance, and that inheritance came through cycles of devastation and recovery that spanned millions of years. 3 major extinction pulses shaped what North America would become. The first arrived roughly 2.6 million years ago, when the planet's climate shifted toward persistent cooling. Temperatures did not drop all at once. Fluctuations created pressure points. Warm phases returned periodically, but each glacial advance that followed came back stronger than the one before it. Species that had adapted to milder climates found themselves trapped. Trees retreated northward. Grasslands expanded. Forests fragmenting into islands of vegetation meant that forest-dwelling animals faced shrinking habitat. Some moved north, some went extinct. The continental ecosystem was being reorganized from the ground up. The second pulse came around 1.5 million years ago. By this time, the giants were already arriving. Mammoths migrated from Asia across the Bering Land Bridge. Camels, which originated in North America, ironically migrated west while their continental cousins were disappearing. The ecosystem was in flux. Predators and herbivores were still sorting themselves out. Small specializations that worked in the previous climate no longer guaranteed survival. Creatures built for temperate forests could not compete with animals built for Ice Age grasslands. Before we continue, I need you to understand something crucial here. The patterns we are uncovering, the mechanisms that transformed North America's animal kingdoms, they are explained in complete detail in our comprehensive guide available in the description and pinned in the top comment. This is a paid resource, but it contains the exact framework that paleontologists use to reconstruct climate-driven extinction and how it directly led to gigantism. If you want to understand not just what happened, but why these specific creatures inherited the world, that guide is where those foundations are laid out step by step. The third pulse arrived between 500,000 and 100,000 years ago. This was when the filtering became absolute. Every interglacial period that returned warmed the planet briefly, allowing some species to rebound, but the glacial advances that followed each time were more severe, more extreme. The animals that survived each cycle were the ones physiologically equipped for cold, the ones that could digest sparse, low-nutrition vegetation, the ones whose body size allowed them to retain heat more efficiently than smaller competitors. Gigantism, it turns out, is an energy solution. A mammoth's body surface area relative to its volume meant it lost heat more slowly than a horse of equal strength. That efficiency mattered when food was scarce and temperatures dropped 50 degrees below freezing. A smaller herbivore needed to eat constantly to maintain body temperature. A massive woolly mammoth could go longer between meals because its metabolism was slower and its insulation was thicker. The predators evolved in lockstep. when large herbivores dominated, large predators followed. A dire wolf pack hunting mammoths needed the mass, the jaw strength, and the coordinated hunting ability that only came with specialization at the high end of the predator scale. Saber-tooth cats similarly had canines that reached 7 inches long because they were hunting prey with thick, layered skin and fur that dwarfed them. Evolution did not create these weapons arbitrarily. It created them because the herbivores they hunted had become enormous. This feedback loop ran for nearly 700,000 years, each cold cycle selected for larger animals. Each warm period allowed the survivors to expand their ranges and refine their specialization. The animals that could not keep pace with this trajectory did not linger in the Pleistocene. They disappeared. Fossil records from across the continent show a consistent pattern. The abundance of small and medium-sized mammals drops dramatically between 2.6 million and 100,000 years ago, while megafaunal remains become more frequent, more widespread, and from larger individuals. The continent that existed 20,000 years ago was not the product of random chance. It was the inevitable outcome of a systematic filtering process that had been running for millions of years. Before we continue, I need you to hold something in your mind for a moment. The ecosystems that welcomed these giants were not stable environments waiting quietly for evolution to fill them. They were active, brutal testing grounds where only the most extreme versions of predator and prey could coexist. And that transformation did not happen by accident. It happened because the extinctions that preceded the Pleistocene had cleared the competition. The animals that had dominated the earlier world, the saber-tooths with modest frames, the elephants with manageable tusks, the ground sloths that never exceeded 15 feet, they all existed in a world crowded with alternatives. Other predators, other browsers, other competitors filling nearly every ecological slot. Then came the extinction events at the end of the Pliocene, around 2.6 million years ago. They were not as dramatic as the Permian extinction that had reset the dinosaur world, but they were devastating nonetheless. Climates lurched, sea levels shifted, forests converted to grasslands. The animals that thrived in those older conditions, the forest-dwelling species, the temperate weather specialists, the creatures that depended on stable moisture patterns, they began to vanish, and in that vacancy emerged something unprecedented. A world that had space for giants. The first woolly mammoth did not suddenly appear 6 million years ago, fully formed with all of its adaptations intact. It evolved, step by step, from steppe mammoth ancestors that were themselves smaller than their Pliocene relatives. But each generation that survived a particularly harsh winter, each individual that could extract more heat from its dense hair or process more calories from sparse vegetation, those were the ones that reproduced. Their offspring inherited those traits. Over thousands of years, those accumulated advantages created something the world had never quite seen before: a herbivore that could thrive in conditions that would have killed its ancestors within weeks. The same process repeated across the continent with subtle but critical variations. Ground sloths grew to the size of elephants because the grasslands supported them and the predators could not. Camels, yes, camels roamed North America during the Pleistocene, developed longer legs and more efficient digestive systems to traverse the vast arid plains. Horses evolved from small forest dwellers into large plains-dwelling runners. The megafauna was not one ecosystem. It was dozens of parallel experiments in gigantism, each species taking whatever evolutionary pathway was available and following it to its extreme. Now, if you want to truly understand how these creatures lived together, how they hunted, how they migrated, how they raised their young in a world this unforgiving, those mechanisms are explained in extraordinary detail in our complete guide on Pleistocene megafauna dynamics. You'll find it in the description, and it's pinned at the top of the comments. It's a paid resource, but it contains the exact patterns and principles that paleontologists use to reconstruct Pleistocene behavior. Worth your time. What emerged from this selective pressure was a hierarchy of predator and prey that made logical sense only within the constraints of that specific moment in Earth's history. The dire wolves hunted in packs because single wolves could not bring down prey animals weighing 3 to 4 tons. The saber-tooth cats relied on ambush and raw power because they lacked the endurance for chase hunts across open terrain. The mammoth mothers bore calves singly, not in litters, because a calf that weighed 200 pounds required intensive parental investment for years before it could survive independently. Every behavior, every morphological adaptation, every social structure, they were all solutions to a problem that no longer exists. That is the critical insight most people overlook. The Pleistocene megafauna were not primitive versions of modern animals, slowly becoming smarter or more efficient. They were highly specialized organisms perfectly calibrated for a world that was itself a temporary configuration. The moment that world began to change, and it would, inevitably, the entire system became fragile. 20,000 years ago, that fragility had not yet become obvious. The ice sheets still covered much of North America, the grasslands still stretched unbroken across thousands of miles, the predators and prey still maintained their ancient dance, but the conditions that had built this world were not permanent, they never are. The climate itself was beginning a slow shift, not rapidly, not dramatically. Over centuries, then millennia, the ice sheets retreated northward, summer temperatures crept higher, winter storms became less frequent. The transformation was so gradual that a single animal living its entire lifetime might never notice the difference. But generations notice, populations notice, ecosystems notice. This is where the inheritance I mentioned earlier becomes crucial to understanding what comes next. The megafauna did not inherit an empty world after the Pleistocene extinctions shaped the landscape. They inherited a world that was actively reshaping itself. The very climate patterns that had allowed them to evolve their massive bodies, their specialized diets, their social structures, those patterns were already being rewritten by forces beyond any creature's control. The ground sloths, those enormous gentle herbivores, depended on a very specific climate zone. They thrived in open woodlands and grasslands where vegetation was abundant but not dense. Their massive bodies required constant feeding. A single ground sloth could consume hundreds of pounds of plant matter every week. This was not gluttony. This was physiology. A body that large simply needs that much fuel to maintain its metabolism and temperature regulation. But vegetation patterns were changing. Forests were beginning to expand into grasslands. The open spaces where ground sloths foraged were slowly filling with trees. What had been ideal habitat was gradually becoming unsuitable. The animals themselves did not migrate quickly enough or far enough to track the shifting vegetation. Their huge bodies made rapid movement costly. Energy spent traveling was energy not spent on reproduction or survival. The dire wolves faced a different problem. These were pack hunters, and packs were only effective if prey was abundant and concentrated. As the climate warmed and the landscape diversified, herds of prey animals began fragmenting. They no longer moved in vast continuous groups. Instead, smaller populations scattered across more varied terrain. Dire wolves could not hunt effectively in this new configuration. Their strategy, honed over hundreds of thousands of years, was suddenly less valuable. Hold on. Before we continue, I need you to notice something critical here. Everything I am describing, the climate shifts, the vegetation changes, the breakdown of predator-prey relationships, this is not happening all at once. These are processes unfolding over thousands of years. Yet all of this information, all of these patterns and mechanisms that separated survival from extinction, they are explored in far greater depth in the complete guide we have prepared on this subject. You will find it in the description and pinned at the top of the comments. It is a paid resource, but it contains the actual data, the timelines, the fossil evidence that shows precisely how these transitions happened. If you want to understand not just what happened, but why it happened and how we know what we know, that guide is where those answers live. The transition was not uniform across the continent. In some regions, the change happened faster. In others, it moved slowly. The southwest remained relatively arid. The Great Plains held their grasslands longer than the eastern regions. The Pacific coast had its own unique trajectory. Megafauna populations responded differently, depending on where they lived and what local conditions they faced. This is crucial. The extinction of the Pleistocene megafauna was not a single event with a single cause. It was a regional, staggered, complex process that unfolded across thousands of miles and thousands of years. Some populations declined gradually, others collapsed suddenly. The pattern varied by species, by location, by the specific ecosystem they inhabited. Mammoth populations in the far north persisted longer than their cousins further south. Woolly mammoths were adapted to cold, dry climate. As the climate warmed, their range contracted northward. They moved toward the Arctic, toward the tundra, toward the areas where ice persisted longest. In those northern refuges, some populations actually survived for another 3,000 years after megafauna had vanished from most of the continent. The last woolly mammoths on Earth lived on islands in the Arctic Ocean, isolated remnants of a world that no longer existed anywhere else. The mastodon, by contrast, was a forest animal. As forests expanded, you might expect mastodons to thrive. And initially, some populations did adapt. They consumed different vegetation, they adjusted their migration patterns. But the forests that expanded were not the same forests that had existed in earlier periods. The composition changed. New plant species arrived, old species retreated. Mastodon populations found themselves in woodlands that looked familiar but lacked the specific plants they relied upon for nutrition. Saber-tooth cats faced pressure from both sides, their prey was disappearing, and the climate was making their hunting strategy less effective. A massive predator that specializes in ambush hunting needs specific terrain and specific prey density. When both changed, the species faced a choice it could not actually make: adapt or decline. Evolution does not work in real time. A saber-tooth cannot choose to become smaller or less specialized. It either finds a way to survive in the changing world, or it does not. The dire wolves had the advantage of being more generalized hunters. They could eat different prey, they could adapt their hunting methods, yet even this flexibility had limits. Packs require social cohesion and successful reproduction. If prey becomes scarce, packs split up. Smaller groups struggle to hunt effectively. The social structure that had defined dire wolf existence for hundreds of thousands of years began to fragment. This inheritance, this world that the megafauna had built and now occupied, was revealed to be temporary almost as soon as it seemed permanent. The Ice Age gave way to the Modern Age, the world changed, and the giants found themselves increasingly out of place in the landscape they had once dominated completely. The transition happened slowly at first. 10,000 years before present, the great ice sheets that had shaped the continent for millennia began their final retreat, not in a single catastrophic collapse, but in stuttering withdrawals and temporary advances. Glaciers that had locked water away for thousands of generations suddenly released it. Rivers swollen beyond measure carved new channels through the land. Lakes appeared where none had existed. Forests advanced where ice had prevented them from growing. For the mammoths, this was not immediately fatal. They had survived previous warming periods. Their thick coats could be shed in warmer months. Their bulk allowed them to thermoregulate effectively enough in moderate climates. Mastodons, built differently, with different dietary needs, faced a more complex problem. The forests that advanced northward replaced the mixed parkland ecosystems that had sustained them. Open feeding grounds became dense woodland. A mastodon browsing on shrubs in open country faced increasing difficulty finding the same resources as trees crowded together overhead. Ground sloths, those remarkable terrestrial giants, faced something different again. The vegetation they depended on, the low shrubs, the grasses, the browsable plants of the cool grassland began to shift. Some species moved northward with the retreating cold, others simply disappeared. A ground sloth dependent on specific plant communities found those communities fragmenting and dispersing across a landscape that was becoming less predictable, less stable. The dire wolves and saber-tooth cats faced the central problem all predators face when their prey becomes scarce or dispersed. Territory sizes must expand. Hunting becomes less efficient. Packs that had hunted together for generations found their established hunting routes no longer productive. The bison herds that had been their primary prey showed new migration patterns. Horses, which had lived alongside mammoths for millennia, began to shift their ranges. Before we continue, I need to pause here for something critical. Understanding what happened next requires understanding not just how these animals lived, but the actual mechanisms of their decline. How exactly species respond to environmental collapse. What triggers extinction in one species but survival in another? This is precisely what I've documented in my comprehensive guide on Pleistocene extinction patterns. The detailed breakdowns of population dynamics, resource scarcity cascades, and the timing of species decline are all laid out in depth. That guide is available in the description and pinned in the top comment if you want to understand the full picture. What made the end of the Ice Age different from previous climate shifts was the rapidity of human dispersal across North America. By 13,000 years before present, humans occupied the continent in meaningful numbers. By 12,000 years before present, they were everywhere that megafauna lived. These were not passive observers of the changing landscape. They were active hunters. The debate about human responsibility for megafauna extinction has raged for decades in academic circles. Did humans kill the mammoths and ground sloths into oblivion? Did climate change do the work for them and humans simply finished off the remnants? The answer is almost certainly both, interacting in ways that varied by location and species. A mammoth population struggling with warming climate faced different pressure than a thriving one. Stressed animals make poor reproductive choices. Cows produce fewer calves. Calves that are born into nutritionally difficult conditions show lower survival rates. Over several generations, population decline becomes inevitable. Insert human hunting into this scenario, even modest levels of hunting, and the math changes dramatically. A population declining naturally can sustain some harvest. A population in collapse cannot survive even light predation. The ground sloths vanished first in many regions. By 11,000 years before present, they had disappeared from most of the continent. Saber-tooth cats followed within 1,000 years. Their entire existence depended on prey large enough to require a pack hunt, and when that prey became scattered and rare, the predator became extinct. Dire wolves lingered longer. Their generalized diet kept populations going in scattered locations well into the terminal Pleistocene. Mammoths persisted longest in northern refugia. Some populations survived until 4,000 years before present in isolated Arctic regions. That was not because mammoths were inherently more adaptable than their relatives. It was because those northern refugia remained cold, remained tundra, remained suitable to their physiology long after southern populations had been swept away. This inheritance that these animals had built, this world of open grasslands and productive hunting grounds, was being dismantled not by one force, but by several acting in concert. And now we arrive at the revelation I promised you at the beginning of this film. The secret that changes everything about how we understand these creatures and why they inherited the world in the first place. Ice Age giants did not lose their inheritance because they were weak. They lost it because they had built it too well. The very adaptations that allowed them to dominate the Pleistocene, their massive bodies, their social structures, their specialized diets, their dependence on megafaunal prey networks, became anchors in a world that was shifting beneath their feet. They were the most successful experiment in large animal evolution that North America had ever seen. And success, in deep time, is often the seed of extinction. The inheritance these Pleistocene titans had claimed from the catastrophes that came before them was always conditional. It depended on climate remaining within a narrow band. It depended on human hunters remaining limited in number and technology. It depended on megafaunal prey continuing to thrive in the proportions that had sustained populations for tens of thousands of years. None of those conditions held. Climate warmed, forests expanded. The open grasslands that had stretched from Canada to Mexico fragmented into smaller, disconnected islands. Mammoths and ground sloths and camels could not move freely between these patches. Populations became isolated. Isolated populations have smaller breeding pools. Smaller breeding pools accumulate genetic damage. Genetic damage reduces fitness. Reduced fitness accelerates decline. Human populations, meanwhile, were not static. They grew. They refined their weapons. They developed strategies for hunting larger animals. They moved deeper into every region where megafauna lived. Some scholars argue that human hunting was the primary driver of extinction. Others point to climate as the decisive factor. The archaeological record suggests they both mattered, and the timing varied by region. What matters for our purposes is this: these giant animals inherited a world that lasted roughly 140,000 years. That is an enormous span in ecological time. But it was not permanent. No inheritance ever is. The Pleistocene inherited by these creatures was built on the bones of mass extinctions that came before. The mass extinctions that shaped their world had created ecological vacancies so vast that nothing resembling modern predator-prey dynamics could apply. A saber-tooth cat did not compete with lions or hyenas or wild dogs. Those animals did not exist in its world. It hunted in an ecosystem almost entirely of its own making, carved from the bodies of species that had vanished millions of years earlier. When those conditions reversed, when climate shifted and humans arrived and megafaunal prey networks began to collapse, there was no fallback strategy. A saber-tooth cat that could not bring down a bison or a horse or a camel could not survive on smaller game. Its entire body plan was optimized for the largest animals on the continent. A dire wolf pack that could not hunt mammoth or ground sloth had no alternate menu to turn to. Their social structure, their pack size, their metabolic needs all demanded large prey. The giants inherited a world, yes, but they did not own it. They were perfectly adapted to one specific set of conditions, and when those conditions changed, as all conditions eventually do, they had no flexibility, no plan B, no evolutionary escape route. They had spent millions of years becoming more and more specialized for that single inheritance. Their strength was also their brittleness. This is what I want you to carry forward. Adaptation is not the same as resilience. Dominance is not the same as permanence. The most successful animals that ever lived on this continent were also among the most vulnerable. They inherited a world by accident of geology and catastrophe. They held it for a moment in Earth time, and when the moment passed, they vanished completely. That lesson belongs to us now. Every dominance ends. Every inheritance is temporary. The only thing that endures is change itself, and the species that survive are not the mightiest or the largest. They are the ones flexible enough to transform, the ones willing to abandon their specializations and try something new when the world demands it. If you found yourself drawn into this story of lost giants and vanished worlds, please subscribe and leave a comment telling me which of these creatures fascinates you most. Was it the mammoths, the saber-tooth cats, the ground sloths? I read every comment, and your response shapes which animals I cover next. Thanks for watching. Hit that notification bell so you never miss a new upload.